Why reality started acting unstable. At first, the failure seemed unrelated. A market crash here, a system breakdown there, small fractures scattered across the world. For decades, stability was the assumption beneath modern life. Infrastructure was designed to endure. Models were built to predict. Risk was quantified, controlled, and insured against. When systems failed, it was treated as anomaly, not pattern. To understand why that confidence is eroding, we need to return to a quiet shift in how reality itself is organized. Modern systems did not become fragile by accident. They became optimized. Efficiency replaced redundancy. Speed replaced slack. Complexity replaced simplicity. At first, the results were impressive. Productivity soared. Costs dropped. Processes synchronized. Everything ran smoothly, precisely because variability had been removed. But beneath that smoothness, something was changing. Systems that once failed gradually began failing suddenly. No warning, no buffer, no time to respond. Stability became brittle. Order existed, but only within narrow margins. This was the first reveal. Instability was not increasing because reality had changed. It was increasing because our systems had. As networks grew larger and more interconnected, small disturbances traveled farther. A minor disruption in one place cascaded across others. Local problems became global consequences. What once remained isolated now propagated instantly. Researchers began noticing the same signature across domains. Power grids, supply chains, financial markets, digital platforms, different systems. Same behavior. They all hovered near critical thresholds, just stable enough to function, just fragile enough to collapse. This raised a troubling question. What if instability was not a failure to be fixed? What if it was a natural outcome of how modern reality had been engineered? And if that was true, then the real danger was not chaos. It was the illusion of control that came before it. As researchers examined these systems more closely, a pattern emerged. Instability did not appear randomly. It clustered around points of maximum efficiency. The more optimized the system became, the less room it had to absorb surprise. Buffers were removed because they looked wasteful. Redundancy was cut because it seemed unnecessary. Diversity was reduced in favor of uniform standards. Each decision made sense locally. Together, they produced fragility. This was the deeper reveal. Stability had been redefined as performance. As long as outputs were smooth, systems were labeled healthy. But health had been mistaken for appearance. Underneath, resilience was eroding. The ability to recover from shock was quietly traded for speed and scale. This became visible during stress. When demand spiked or conditions shifted, systems did not bend. They snapped. Failures cascaded faster than humans could respond. The very connections that improved efficiency now transmitted breakdown. Researchers turned to complexity theory for answers. They found that highly optimized systems naturally migrate toward critical states, places where small inputs create large effects, not because of error, but because optimization pushes systems to their limits. This explained why prediction began failing. Models assumed linear responses. Reality responded nonlinearly. Tiny events triggered disproportionate consequences. Cause and effect decoupled. Control lagged behind change. The conflict sharpened when decision-makers realized the implication. Instability was not something to eliminate. It was something to manage. Attempts to suppress volatility often made it worse. Artificial stability delayed adjustment. Pressure built silently. When release finally came, it was explosive. The systems were not misbehaving. They were obeying the logic they were built on. And that logic was pushing them toward a breaking point. The question was no longer why reality felt unstable. It was how close we already were to the edge. The conflict reached its peak when instability stopped being theoretical and became personal. Disruptions were no longer abstract system failures. They affected livelihoods, trust, and daily life. What once felt distant now felt constant. Researchers noticed something unsettling. The warning signs were always present. Fluctuations increased. Recovery times lengthened. Small shocks produced outsized reactions. The signals were there, but they were ignored because the system still appeared functional. This revealed a dangerous blind spot. Modern systems were optimized to look stable, not to be stable. As long as outputs remained smooth, internal stress was invisible. Instability accumulated quietly, hidden by performance metrics that rewarded short-term success. This mirrored a pattern seen in nature. Forests suppressed from burning eventually ignite catastrophically. Rivers confined by levees flood violently when breached. Stability in force 2 rigidly eliminates natural release mechanisms. The same dynamic now governed human systems. When variation was suppressed, adaptation stalled. When adjustment was delayed, collapse accelerated. The systems were not failing randomly. They were failing predictably, according to the logic of over-optimization. The emotional buildup intensified when researchers realized how difficult reversal would be. One system scaled globally. Reintroducing slack becomes expensive. Redundancy looks like inefficiency. Diversity looks like disorder. Yet without them, fragility remains. This forced an uncomfortable admission. We had engineered instability into the foundation of modern life, not through neglect, but through success. The very tools that created unprecedented efficiency had also removed resilience. Stability became conditional, dependent on everything going right all the time, and that condition rarely holds. The question was no longer how to restore control. It was whether control, as we defined it, was ever the right goal. The climax arrived with a realization that reframed instability itself. Reality was not becoming chaotic. It was responding honestly to how it had been structured. Systems optimized for efficiency naturally drift toward the edge of failure, not because something went wrong, but because optimization removes tolerance. When every part is tuned to perform perfectly, there is no space left for surprise. This insight dissolved a comforting myth. Stability is not a permanent state. It is a balance that must be continually maintained. When balance is replaced by maximization, instability is not a risk. It is an outcome. The resolution was not a call to abandon complexity, but to rethink what strength looks like. Resilient systems are not the fastest or the most efficient. They are the ones that can absorb shock, adapt without panic, and recover without collapse. This matters now because the pace of change is accelerating. Technology scales faster than understanding. Interdependence grows tighter. Small decisions ripple outward with increasing force. In such a world, fragility hides behind success until it suddenly cannot. Instability then becomes a message, a signal that systems have been pushed too far in one direction. That slack, diversity, and redundancy are not flaws to be removed, but features that keep collapse at bay. Reality did not start acting unstable without warning. It responded exactly as complex systems always do when flexibility is stripped away. The challenge ahead is not to eliminate instability, but to live intelligently with it, to design systems that expect disruption instead of denying it, to value resilience as much as performance. Because a world that never shakes is not strong. It is already broken. And sometimes the smallest shift in perspective becomes the beginning of a new future.